second part of my lecture of power flow solution. So in this part, I'll discuss the solution method of load flow studies. That is how we can solve the load flow problems. So we have to determine the bus voltage and magnitude of a particular power system network. So for this reason, there are several load flow methods. So Gauss-Seidel method is one of them. So Gauss-Seidel method is an iterative solution process. By using this process, we can find out the bus voltage and angle. So first we have to know the equations of Gauss-Seidel method. So according to Gauss-Seidel method, if we want to solve any load flow problem, so we know in a power system there are three types of buses. Number one, the load buses. Number two, there will be generator buses. And finally, there will be a single slack bus or reference bus. So in a particular power system here, if we consider there are 4 bus power system, and for this particular power system, if bus 1 is a slack bus, it means that it is a generator bus, and it is a such kind of bus for which bus voltage and magnitude and angle we know. So we don't need to calculate anything at first for this bus. Next, bus 2, 3, and 4 all are the PQ buses. So if this 4 bus power system, bus 2, 3, 4 are PQ buses, then if we want to find out the voltage magnitude and angle for bus 2, then the equation should be like this. So this is the complex power equation which is injected from bus 2. So the equation should be P2 minus JQ2 is equal to V2 conjugate into current, that is I2. So this is the V2 conjugate and this is the current equation. So from this power equation, we have to determine the voltage magnitude angle of bus 2. So we have to calculate this V2. So V2 should be the left side of the equation and all other thing should be in the right side. So this is the final equation. By using this equation, we can calculate the bus voltage and magnitude by using this method. So if bus 3 and bus 4 all are the PQ bus, then this is the equation for bus 3 and this is the equation for bus 4. So these are the equations. By using these equations, we can calculate the voltage magnitude and angle. So here, this is the general equation actually. So equation number 16. So this is the general equation. By using this equation, we can easily calculate the bus voltage and magnitude of such kind of power system actually by using the Gauss-Seidel method. So if these all are the load buses, then this is the general equation of Gauss-Seidel method to find out the bus voltage and magnitude. So this is the general equation. Now, if we want to calculate the voltage, magnitude, and angle of bus 3, then V3. So V3 is equal to, so here we calculate the voltage, magnitude, and angle of bus 3. So here I should be 3. So I should be 3. So here I should be 3. And the total number of bus here 4. So in this power system, total number of bus is 4. So now we calculate the bus 3 voltage and magnitude. I mean bus 3 voltage, magnitude, and angle. So V3 is equal to, the general equation is 1 by YII. So Y is the Y bus matrix element I. So the value of I is 3 here because now we find out the voltage, magnitude, and angle equation for bus 3. So I should be 3. So now the equation will be 1 divided by Y33. So 1 divided by Y33. So this is the equation. 1 divided by Y33. So this is the equation. So now P minus JQ by V conjugate. So here the I should be 2, 3, because we calculate for bus 3. So I should be 3. So the equation should be P3 minus JQ3 divided by V3, that is the conjugate. So this is the equation actually. So this is the equation. Now once again minus. So this is the minus. J is equal to 1 up to I minus 1. So here the value of I is 3. So J should be 1, then J should be 2, and then J is not is equal to 3 because here I is equal to 3, and J should be goes up to I minus 1. I minus 1. So here there should be two terms. One for J is equal to 1 and another for J is equal to 2. So there will be two terms here. So minus for J is equal to 1, Y, that is I is equal to 3. So Y31 into V1. So the equation should be Y31 into V1. So this is the equation actually. Y31 into V1. So next, minus the second term should be J is equal to now 2. So Y32 into V2. So that is Y32 into V2. So this is the equation, Y32 into V2. So now J is equal to 3, but here I minus 1, so up to 2. So J should not is equal to I. So this term is finished now. So this move on the next term. So here J is equal to I plus 1 up to capital N, that is the total number of bus. So I is equal to 3, so I plus 1 means 4, and the total number of bus, that is the capital N, is equal to 4. So total number of bus is 4. So 4 to 4, so there will be a single term. So there will be a single term, and that is I is equal to 3 and J is equal to 4. So 34 Y34 into V4. So here should be Y34 into V4. So this is the final equation, Y34 into V4. So this is the final equation. So if there be a 4-bus power system and we want to calculate the bus voltage magnitude and angle for bus 3, then by using the Gauss-Seidel method, this is the equation. So by using this equation, we can easily calculate the voltage magnitude and angle for bus 3. So this is the general equation, and this is the procedure, how we can elaborate this general equation. So now for another example, now we consider there are 6 buses in this power system, and we want to calculate the current of bus 4. I mean, not the current actually, the bus voltage and magnitude of bus 4. So the value of I is equal to 4 now. So if this is the condition, this is the new problem, and if this is the condition, then what actually? So here there should be V4 because we want to calculate bus 4 voltage, and total number of bus of the power system is 6. Now 1 by Y, so 1 by Y II, this means that 1 by Y 4 into P3 minus JQ3. So here Pi minus JQI, so I is equal to 4. So P4 minus JQ4 divided by V4 conjugate minus J is equal to 1 up to I minus 1. I is 4. So 1 up to 4 minus 1, that is 3. So 1 to 3. So there should be 3 terms. 1 to 3. So there should be 3 terms. So I is equal to 4. So there will be 3 terms. So 4 1 into V1 minus 4 2 into V2 minus, that is 4 3 into V3. So 41 into V1, 42 into V2, 43 into V3. So next here, that is I plus 1 up to n. So I is equal to 4. So 4 plus 1 means 5. So 5 up to the total number of bus is 6. So 5 to 6. So there will be 2 terms. So there will be another 2 terms. So if another 2 terms, J will be a start up to 5 and goes to 6. So up to 5. So J should be 5 and I is equal to 4. So Y, that is 4 5 into V5 and minus Y 4 6 into V6. So this is the final equation. So this is the final equation. By using this equation, we can easily find out the bus voltage and magnitude by using the Gauss-Seidel method for any kind of power system. So this is the equation actually. So how we can elaborate this general equation. So this is a general equation, and I described this general equation already. Now we know that there will be generator buses for a particular power system. So if there will be generator buses, then it is called, we can call this is the PV bus. So if there will be PV bus in a power system or a particular power system, then this particular bus type, we don't need to identify the voltage magnitude, because the voltage magnitude is already given in the question. So we don't need to determine the voltage magnitude. We just need to determine the voltage angle. So we have to determine the voltage angle for a bus which contains generator. And now this is the equation actually. If we just put the values in this equation, we can easily calculate the bus voltage magnitude and angle. So we can use this equation to determine the angle of any particular bus voltage, but the magnitude is given if the bus is PV buses. So we don't need to take the magnitude. We just need to take the voltage angle. So we just need to consider the angle of this particular, from this particular equation. So the equation is, that is the voltage angle equation, delta, and to determine the delta, the equation will be same, but we just need to consider the angle from this equation. And I already discussed this equation, just we need to consider the angle from this equation. Now to consider the angle from this equation, we have to determine the voltage. Now we need to determine the angle actually. So this is the equation. So now for this equation, if I want to calculate the angle of bus 3, then there should be del 3. And now if it is del 3, then this equation, that is the P3 minus JQ3 divided by V3 conjugate. But if we want to put here P3 minus JQ3, but this is a particular generator bus, that is the PV bus. So we don't know the reactive power of this particular bus, that is the Q. Q is not given because this is not a load bus, this is the generator bus. This bus contains a generator. So for this type of bus, P and V is given, but not Q is not given here. So for this reason, at first we have to determine the reactive power of this particular bus. Once we know the reactive power of this particular bus, then we can use this equation to find out the voltage angle. So at first we need to know the reactive power of this particular bus. So this is the equation to find out the reactive power actually. So we know this equation. This is Q, so minus Im means imaginary part. So this is a complex power equation, voltage conjugate into current. So if we solve this equation, we will find out a particular solution which contains a real part and a imaginary part. But we don't need to consider the real part, because here real power is given in our question, because this is a generator bus or PV bus, so real power is given. So we need to consider the reactive part of from this equation or from the solution. We need to consider the reactive part. So that's why this is the Im sign, that is the imaginary value. So we need to consider the imaginary value from the solution. So this is the equation. If we put down the value here, we will get the reactive power. And we know the reactive power equation very much, because in my previous lecture I describe how we can write the power equation. So here one example is given. If we consider bus 4 is a generator bus for this particular power system, if we consider bus 4 is a generator bus, then the reactive power of bus 4 Q4 should be minus, that is the imaginary value, voltage conjugate, that is V4 conjugate into I4. So the current injected from bus 4. So the equation should be y41 into V1 plus y42 into V2 plus y43 into V3 plus y44 into V4. If there will be 6 buses for this particular power system, then the current equation should contain 6 parts. So then that should be y45 into V5 plus y46 into V6. So this is a particular equation. If we put down the values in this equation, we will get the reactive power. And after getting the reactive power, if we put down the reactive power value in equation number 18, then we can calculate the voltage angle. So after find out the voltage angle, we have to upgrade our values, voltage values. So if the bus 4 is a PV bus and the voltage magnitude is given in question like 1.5 per unit, then the magnitude is fixed. So there should be 1.5 per unit, the magnitude is fixed. And here we can consider the only angle. So cos delta plus j sin delta. If we multiply this with the voltage magnitude, we can upgrade the voltage value actually. So this is the upgradation process. So now this is our equation to solve the load flow study by using the Gauss-Seidel method. So these all are the equation to solve this particular problem. So one thing I still don't discuss, and that is the fact of k here. This is the k. So what is the matter actually of k? So k is the iteration number. So k denotes how much time you took the iteration actually. So the number of iteration. If a particular solution need 4 calculation, so k should be 1, 2, 3, 4 up to 4. So k is represent the number of iteration. So here why this k is needed, or why this several number of iteration is needed, because in this solution, whenever we want to calculate the voltage magnitude and angle of V2, then we need to know the voltage conjugate, V2 conjugate, but we don't know the V2 conjugate, because we are just beginning to start the solution of V2. So we don't know what is the value of voltage conjugate V2. So this is the unknown quantity. Again, we don't calculate the V3 and V4 yet. So we don't know the V3 magnitude and angle value, and we don't know the V4 also. So these V3, V4 and V2 conjugate all are the unknown quantities for this particular equation. So if there will be several unknown quantities in this equation, then we can't solve this equation actually. We can't solve this equation. So to solve out this problem, there is a technique, and that is we can assume the value which we don't know. We can assume the value. So If we don't know any voltage magnitude, we will assume it 1 per unit. And if we don't know the angle of any voltage, bus voltage angle, we will assume it at 0 degree. So if we assume this 1 angle 0 degree, then the V2 conjugate should be 1 angle 0 degree, that is 1 minus J0, and that is the V3 should be 1 angle 0 degree, V4 should be 1 angle 0 degree. So if we put down this assumption value, then we can find out values for V2 actually. So these 0, this to the power 0 actually, this means that this is the assumption value. V1 is the bus voltage of slack bus, that is the given, and we don't need to assume this because this is the given value. But this 0 means that these are the assumption value. And here, whenever we calculate the bus voltage of V3 or bus 3, then V2 should be 1. It means that here we don't need to put down the assumption value because we have already calculated the value of V2. So here we can put down the early calculated value here, or the first type interaction value here. So that's why V2 to the power 1. It means that put down here the first iteration value of V2. And this is the V2 V4 0. It means that we don't know the value of V4, so we have to put here the assumption value of V4, that is 1 angle 0 degree. And whenever we calculate the V4, then V2, V3 we have already known because we calculate this, but we don't know the V4 conjugate, so we have to put down this assumption value. So 0 means the assumption value, and this one is the iteration number. Now, after solving this equation, we will get down the values of V2, V3, and V4. But one is the thing that we find out these values by using some assumption. We don't know these assumptions are true or false. We don't know. But to find out the solution, we just take some help from the assumption value. So we need to determine that these values are correct or not. So for this, we need to satisfy the tolerance level. So what is the tolerance level? Tolerance level means the mismatch actually. So if we want to calculate, that is we want to satisfy the tolerance level, that is V2. So that is the V2, means that voltage of bus 2, and if we consider this as the second time interaction, this is the value of K actually. This is the value of K, that is the second time interaction. So that should be minus, that is the value of 1. This is the first time interaction. So this should be the delta V2. So delta V2 means, so that should be the delta V2. So delta V2 means the difference actually. Delta V2 means the difference. So this is the tolerance level. If this difference is equal to 0, it means that what the voltage magnitude and angle we have find out after the second iteration, this is the answer. This is the answer. And if this value is like 0.0005, that is, this satisfy the tolerance level because this is less than 0.001. And if we consider this 0.001 is our tolerance level, then this is the less than value of tolerance level. So here still the voltage magnitude and angle value we have find after the second iteration, this is the final result. And if this actually this result is not satisfy the tolerance level like 0.1, which is the greater than of the tolerance level value. So it means that the solution is not complete yet. Again, we need to determine the voltage value for third time iteration, and this is goes on, and like look like this. After the 20th iteration, if this value is satisfy the tolerance level, that is look like this. So this is the less than of our tolerance level value. So it means that now the tolerance level is satisfied. Then the voltage magnitude at angle after 20th iteration, this is our answer. So this is our iteration, your iterative method. We need to solve the equation for several times to find out our desired solution. So this is the solution process, or how we can solve our load flow studies program or problem by using the Gauss-Seidel method. Now this is the Nagrat Kothari book, Modern Power System Analysis, Nagrat Kothari. So this is the chapter 6, that is the load flow study chapter, and this is the Gauss-Seidel method. So in this reference book, the Gauss-Seidel method is details described. So you need to study the method from this reference book. So now there is a example, that is the example 6.4. So this is a table. There are 4 buses of this particular power system. Bus 1 is a slack bus, and all other buses are the PQ bus. So we need to determine the voltage magnitude and angle for bus 2, 3, and 4, because these all are the PQ buses. So bus 1 is a slack bus, so voltage magnitude and angle is given. Magnitude and angle are given, and all other buses, the P and Q, these values are given because these are the load buses. Now we have to determine the voltage magnitude and angle for load buses at the end of first Gauss-Seidel interaction and the end of first Gauss-Seidel interaction. So to solve this particular mathematical problem, we need to know the bus admittance matrix, and bus admittance matrix we find from figure 6.5. So if our previous example, actually for previous example, figure 6.5, well, for this is the figure 6.5. So in this mathematical problem, actually here this is the bus admittance matrix, and for this particular mathematical problem, this bus admittance matrix is used to solve the load flow problem. So now, so if we want to calculate the bus voltage of 2, so this is the equation. So we need to put down all of the values here. Just so we don't know the bus voltage and angle of bus 4 and 3. So here the assumption is 1 angle 0 degree. So 1 angle 0 degree not written here, because if we multiply something with 1, the answer will be unchanged. So after putting down the value and by solving the equation, this is the answer. So for bus 3, the bus voltage V3, then for V3, we here that should be V2 actually. They notice V3, V2 first time interaction. So the V2 first time interaction value is 1.01 plus J 0.046, and this is 1.019 plus J 0.046. So we have to put down the first interaction value of V2. And similarly for V4 also. So this is the solution of this particular mathematical problem. So for this particular problem, if bus 4, bus 2 is a PV bus. So now we have to consider bus 2 is a PV bus. So if bus 2 is a PV bus, then the voltage magnitude of bus 2, that is V2 magnitude, is 1.04 per unit. This is given in the question. So we have to determine the unknown quantities at the end of first Gauss-Seidel interaction. Now this bus 2 is a PV bus. So at first we need to determine the reactive power of bus 2, and the range of reactive power is given 0.2 to 1. So whenever we just find out the reactive power, the answer we have find here 0.2079, which is satisfying the range. So we can consider this Q2 as our solution, or the reactive power of bus 2, and by put down the reactive power value is here, we can just find out the angle delta 2. So now we have to convert this angle to radian, and then we can upgrade the bus voltage of V2. The magnitude 1.04 is fixed because this is the given in the question, so we don't need to change anything in this section. So we have to just consider the angle, and now we can update the value of V2. And now we can calculate the V3 and V4 by put down the update value of V2. So if the range is now changed 0.25 to 1, and we find out the Q2 is 0.2079, which is the below of the lower limit. So if this value is below of the lower limit, then we cannot take this value actually. So we have to consider the lower limit value as the our reactive power value of bus 2. So we have to consider this 0.25 Q2, and here we have to put down this value. And if we can find out, our answer look like 1.2 per unit Q2. So if the Q2 is exceeded the upper limit, then we will consider the value of Q2 is the upper limit. So the value of Q2 or the value of any generator bus, if the range of reactive power is given in the question, then we have to consider the range. So if our solution is between the range, we can take down our solution. If our solution is lower from the lower limit of the range, we have to consider the lower limit. And if our solution is above from the upper limit, we have to consider the upper limit. So this is the solution process by using the Gauss-Seidel method. So that's all about the Gauss-Seidel method.